Hi, welcome back. We'll continue the International Baccalaureate Chemistry exam class 2. In this topic, acids and bases, another question we are considering. We can read the question. Separate a 20 cubic centimeter solution of a weak acid and a strong acid of the same concentrations are titrated with a sodium hydroxide solution, which will be the same for those two titrations. There are three cases. One, initial pH will be the same. Two, pH at equilibrium point will be the same. And three, volume of NaOH required to reach the equivalent point will be the same. Among the three options, we have to arrive at the answer, the correct choice A, B, C, D. Whether one is one only, three only, one and two only, and two and three only. For solving such a type of problems, we have to understand that we are using a same concentration of weak acid and strong acid solutions. Weak acid means not completely ionized, and strong acid will be preferably completely ionized one. Or the same concentration, they are having same concentration, but the percentage of ionization will be different. In that situation, we are using the sodium hydroxide solution, which is a strong base. During that, what will happen for the initial concentration? Initial pH will be different because what reason? We are using a weak acid for the first case and then a strong acid. For that, the pH value will be less. We know that the acid pH will be smallest for a strong acid, and it will be closer to 7 for a weak acid, because water is having a pH 7. Less than that will be the acid, and 7 and less than that will be acid, and 7 and above that will be bases. So lesser the pH, stronger the acid. And if it is closer to 7, that will be the weakest acid. But sodium hydroxide is a strong base. In that case, initial pH will not be equal always. So option 1, that is the one only answer, initial pH will be the same, is wrong. Now what about the third one? Volume of NaOH required to reach the equivalent point. That will be the same, because same concentration of acid we are using, and it will give almost equal value for NaOH. Almost a concordant value will get for this case. So 3 only answer is not correct. 3 is correct. So we have to check whether C and D are possible. For that, we have to understand that the percentage of ionization of initial concentration of an acid, the dependence of percentage ionization on initial concentration of the acid is there. That means if initially we are taking very dilute solutions, the extent of ionization will be almost equal. For very low concentrated strong acid or weak acid, the percentage of ionization will be almost equal. Or in other words, all weak acids tend to be 10% ionized, almost 10% ionized, if the initial concentration is lower and lower. So in this typical case, we can say that 3 will be correct, because the ionization is almost equal and the volume of NaOH used will be same. So what happens? The option 2, the D, that is 2 and 3 will be the same for this titration will be correct, or we can say that D is the best answer. I will come once again the important point. We are not selecting A because initial pH will not be equal for a strong acid and weak acid. And pH at equilibrium point, that will be same. At equilibrium point, the extent of neutralization takes place. The acid and base react and the pH will be almost equal to 7 at equilibrium point. So 2 will be correct. And the third argument is that for any acid, strong acid or weak acid, the percentage of ionization will be tending towards 10% at a very low concentration. In that case, 3 also will be correct. So 2 and 3 option will be correct for this particular question, and A will be definitely wrong, and therefore C also will be wrong. B is correct, but apart from B, 2 also is correct. Therefore the best answer is D. D is selected as the best answer. Okay, we'll continue in another class. Okay, bye.